session will be Anova. So we are going to combine both the theoretical part and the calculation part. I'll be as basic as I can so that you're able to understand fully what is involved. So what is Anova? What is the purpose of Anova? And what are the key assumptions under Anova? So I must submit to you that Anova is the easiest topic in this course. So by definition, Anova, with the acronyms ANOVA, stands for analysis of variance. So it is used in statistics when you're comparing more than what? Three means, three or more independent groups to determine the significance between them. So the purpose for ANOVA is basically to test the null hypothesis that all the group means are equal. All right. So there's what we call a one-way ANOVA, a two-way ANOVA, and these are the common ones. So what is the purpose and what are the assumptions? The purpose of ANOVA is to measure what? The differences between more than two or three means. And what are the assumptions under which ANOVA operates? The following are the assumptions. Number one, the assumption is that there should be independence. Okay, independence of observations. So each sample or group must be independent of each other. Number two, normality. So the data group of each group must approximately be normal. And also the variances from each group must roughly be equal. These are three assumptions. The purpose is to determine whether there is a statistical difference between more than two groups. So it's three and above. It also helps us to avoid the t-tests, to avoid multiple t-tests. So it increases the risk of making the type 1 error. And it is used when you're using what? Random randomization or random experiment. So for ANOVA, firstly, you need to understand how to balance up the ANOVA test, ANOVA table. So, well, what we call a one-way ANOVA. So it has the following. There's three main sources. So we have source. What are the three sources? Number one, between. Number two, within. And number three,
Total.
the total. Okay. So these are the three sources. So we use the acronyms SS. So this is sum of square between, we put SSB. Sum of square within, SSW. Sum of the square total, SST. All right. Then when we go to the degree of freedom, here the degree of freedom for a one-way ANOVA is K minus 1. Here the degree is N minus K. Then here the degree of freedom is N minus 1. Then we have the mean of squares, and we also have the F calculated. So here, if we're going to divide this in there, maybe we'll get our answer as A. If we divide this into there, we get our answer as B. The F calculated is simply when you divide A over B. That is how we get the F calculated. So what is this K? K is a number of treatments. So we have treatment 1, treatment 2, treatment 3. So these are more or less columns. So for instance, we have a number here, 3, 2, 1, 3, 4, 2, 5, 1, 1, 2, 3, and 4. So the number of columns, we call them what? The treatments. The letter we use is letter K. So what is our K in this case? Our K is what? 3. Because we have 3 treatments. Then n is the total number of observations. How many elements we have? There's 4, 4, 4. In total, we have 12 observations. So our n is what? 12. Are we together? So these are the key parameters that I need you to understand. Then to calculate, you need to calculate the sum of square between and sum of square within. I'll teach you how to calculate, but usually in the exam you are given. So I'm going to put figures there. So maybe you can say here it is 30 and here is 27. So I want you to learn how to balance up this ANOVA table. So there are 3 sources. What is our sources again? We have our sources what? Between. We have our sources within. We have our sources
and,
and
total.
total. Okay. So our sum of square. So our sum of square between. What is our SSB according to the data we have? What is our SSB?
30.
20. So 30. So we put 30 here. What is our SS between? Yeah, within
27.
27. So meaning what becomes our SS total? We just total up here, which is 50 what? 57. So this
51.
information is just from there. I want you to learn how to balance up because balancing up is the most important thing. What is our degree of freedom for between? K minus 1. All right? And what is our K here? What is our K? 3.
3.
How do we get the 3? The number of columns. So what is 3 minus 1?
That's 2.
2. So 2 into 30, we put 15.
15.
Let's go to the next one here. How do you find the degree of freedom for within? N minus what?
Okay.
N minus K. What was our N?
12. 12.
12 minus 3?
That's 9.
So 9 into 27? It's 3.
3.
The total here on the degree of freedom, we get what? 11. And the last column is the F calculated. What did you say to find the F calculated? It is A over B. Divide this answer in there. So what becomes our F calculated here?
5.
5. How do you get the 5? 15 divided by?
3.
Okay. So this is the most important part, okay, of your, because it will give you um, good marks to understanding that. All right, so let's get to our exam question, which came last year. I just want you to do the together. Let's do the table for this paper. So we are assuming the assumptions for ANOVA, okay? So let's identify what is our K, what is our K? Give me the K, give me the N, give me the SSB, give me the SSW. What is our K?
That's 48.
Our K,
So it's 3. Sorry.
3.
3.
Our N,
That's 25.
1, 2, 3, 4, 5.
15.
5 times 3,
Ish.
50. And what is our SSB? 432 point what? 133.
1333.
And what is our SSW?
234.72.800.
Okay. So help me now come up with the ANOVA table. So how do we do the ANOVA table? What are the three sources?
It's between,
So we have between, within, and what? Total.
total.
So what is the sum of square between? 432.133. Within 2372.800. Total, we just total up there. What are we getting? 33394
That's 94082.
082. Okay, then how do you find the degree of freedom? A minus 1. So here we're going to have
2.
2. Then here, what is the degree of freedom?
12.
12. How do you get the 12?
N minus 3.
And here, what do we get? 14. Or n minus 1. 15 minus 1 is 214. Then how do you get the mean of squares? We divide this in there, this in there. So what is the mean of squares?
Two 16.0
16.0
465.
465. Okay, then here we're dividing this in there.
197.7
127.
Why were you dressed like that?
0.73.
Okay. So 197 was 19.
0.7
0.7.
7 triple or 3.
3.
Okay. So how do we find the F calculated? Divide the mean square between, mean square within into mean square between. So this answer is given.
1.5.
1.093.
1 point.
I found 1.093.
I found 1.598.
Okay, the difference is very minimal. Okay, so this is how you come up with the ANOVA table. Then you are going to be asked to test it. So far, when coming up with the ANOVA table, are we all clear?
Yes.
Yes.
Right. So you cannot forget to remember this, isn't it? Just into practice. So now the second part of it requires you to understanding how to read what we call the F table. So F table is based on the levels of significance. So we have a 1% F table, 5% F table, 0.1 F table. So now, in coming up with the F table, we always reject if our F calculated is more than our test statistic. So in this case, we need to go to our statistical table. We have a table there with you.
No, I don't have.
Okay, but let me teach you how to um, read them. I'll use mine. Okay, statistical table. So I need you to be very careful in understanding how to read this. So when you go to the F table, it's at the bottom most at the last. So this is a 1% table. So it's continuous here. So you use the degree of freedom to read your F tables. So here at 1%, what are the coordinates? You get them from here, 2, 12. So if the answer we get is more than, if this is more than what is in the table, we reject. So how do we read this 2, 12? The 2 will be coming from the top. The 12 will coming from down there where they meet. This is called our F reading. So let's go to the F table where 2 and 12 meet. So 2 and 12, where do they meet? 6.93. 6.93. All right. So 6.93, that is our reading. So is this more than that? No. So we can say since F calculated, which is 1.59, is less than what we found in the table, 6.93. What do we do? We accept HO. By accepting HO, we mean there's no significant difference between the means. Whenever there's a difference between the means, it means that we are rejecting HO. So it is always a good thing whenever we're rejecting, meaning there's a statistical difference. So our test statistic from the table is 6.93. Any answer we find in the shaded region here is called the rejection region. So in our case, our answer is too small to reject. It's somewhere here, 1.5. So this simply means that there's no difference between the methods. The methods have no significant effect. So this is how we answer that Anova question. Is that clear?
I think, is it okay if you repeat this part for me? Sorry, I got a little bit distracted side.
Okay, so we were given the sum of square block and the sum of square within. These are the two figures there. So how did we get these two? The k minus 1. So our k in this case was 3. With the 3 columns. 3 minus 1, that is a 2. So 2 into there, we got that figure. Our n was what? 15. So 15 minus
10, yeah.
3, we found this 12. So 12 into this figure, that's how we got this.
Yes.
Here, it's just an issue of totaling up. The f calculated here, we divided this 197 into there. That is our what? 1.5. So what remains
Yes.
now is to make a decision. So the decision basically is about calculating the f tabulated from the table. How do we get the f tabulated from the table? We get the coordinates 2, um,
12.
12. All right? Are we together? 2,
Yes, yes.
12. Patricia, are we together at the same time?
Yes. Yes, yes.
Okay, so if it's okay, how do we get this 6.93? 6.93, we found it 2.12. So 2.12 we read from the table. 2.12 where they're meeting, it is 6.93. So we only reject if this one is more than that. But since this one is less than that, we accept. All right. So our decision here to fail to reject is on account of the fact that there is what? No difference in there. Is that clear?
It's now clear.
Yeah. All right. Do we do another example or we're good to go?
I think we're good to go.
So we now go to a question to do with regression. We look at the question on regression if that's clear. So regression is about relationships. So relationships exist in causal relationships. Okay. So relationships are important because they help us measure or determine causality. So what is regression? A definition, regression can come in terms of what we call linear regression. Okay. Come in terms of multiple regression. You want to measure how the dependent variable affects the independent variable. So it has a few assumptions also that you can get to know. So just go through a few brief notes. So regression is used to analyze relationships between one dependent variable and one or more independent variable. It is used to predict how the dependent variable are based on the independent variables. It helps you to identify the trends, the strength, and the direction. The regression is given by y is equal to a plus bx, where b is a gradient, a is a intercept, the cutting place. So relationships can either be positive and strong. Relationships can either be positive and weak. And the dots are further away from each other. This is weak. So the positive relationship is coming from the fact that your RI is a positive. Okay, we also have a negative relationship where relationships are opposing each other. For instance, demand has a negative relationship. When the price of a commodity goes up, the quantity demanded of a commodity will do what? Will go down. So that is the negative relationship. So we have a positive relationship that is negative. We have a negative strong and negative weak. So how do we know it is weak? We use the symbol R squared. When R squared is more than 50%, we say it's strong. When R squared is less than 50%, it is weak. So what determines the strength of the relationship is the R squared, which we call the coefficient of determination. R squared is the coefficient of what? Determination. If it's less than 50%, it is weak. Sometimes if you're in marketing, you can want to ask your managers whether they will support you in an advertising campaign. But for them to support you, you produce what is called your R squared. R squared, if for instance you have 0.80, it means that 80% of your advertising will contribute to your sales. So R squared means coefficient of what? Determination. The R on its own is called the coefficient of correlation. It's either you have a negative or a positive. So if it's 0.8, this means it's a negative relationship. It looks like this. If your R is positive 0.8, it means a positive relationship. It means by adding one value, it will increase on the other. So you need to understand that regression is mainly about seeing how the independent variable affects the dependent variable. So this is the independent variable. This is the dependent variable. So examples of independent variables. So the independent variable, the dependent variable is the result. You may have sales and advertising. So sales is an independent variable. Which one depends on the other? Okay, so now I need you to understand a few formulas here as we get to break down um, our question. Are we together so far? Any question?
Following, no questions for now.
Yeah. So we're going to look at an example, then we'll look at the exam question. So we've talked about the regression equation, which is given by the following formula. Our formula for the regression equation is y is equal to a plus b plus the error term if you want. So if you have x and y, maybe this is 1, 2, 3, 4, 5. This is 1, 1, 2, 2, and 4. So you have x and y. You want to come up with the regression equation. So you can multiply them, x, y. You can square them individually, x squared and y squared. So what are we getting here? 1, 2, 6, 8, and what? And 20 by multiplying them. Then let's square them here. 1, 4, 9, 16, and what? And 5. Then here we have 1, 1, 4, 4, and what? And 16. So this is called the sum of x. In total up, this is sum of y, sum of xy, sum of x squared, sum of y squared. So in the total up here, what do we get? 5, 10, 15. In total up here, what do we get? 8, 10.
That's 12. 10, yes.
Here, in total up, what are we
11.
getting? 37. Here in total up, what do we get? 55. Here in total up, what do we get? 26. So how do you come up with the regression equation? Y is equal to a plus bx. So you need to find your b before finding your x. So b stands for the what? For the slope. A stands for the y-intercept. Are you following so far?
Yes.
Patricia, are you following? Right.
Yes, I am.
So how do you find the b? The formula for the b is n summation of x squared minus summation of x. Can someone give me the formula for b? xy, summation of x, and summation of y. You should have these formulas at your fingertips. Divided by n summation of x squared minus summation of x summation of y to the power 2. So n is the number of what? Rows we have there. 1, 2, 3, 4, 5. So our n is 5. We'll substitute here. What are we going to have? 5. Xy is what? 37. X is what? What's summation of x? 15. Summation of y? What is summation of y?
37.
Pardon?
Estimation of y, that's
10.
mhm.
Then down there, our n is still 5. And what is summation of x squared?
5, 5, 55. XY squared.
Then summation of y?
That's that's 10.
Yes,
That's
10
100.
power 2. So you need to differentiate summation of x squared and summation of x to the power 2 or y to the power 2. So here, when you calculate properly, your b is going to give us 0.7. Okay. The formula for a is summation of y over n minus the b you just calculated over summation of x over n. What is summation of y? 10
That's 10.
divided by n,
That's 5.
right? Minus what is our b?
0.7.
What is summation of x
That's 15.
over n?
5.
5.
5.
So 10 divided by 5 is 2. 0.7 times 3 is 2.1. So 2 minus 2.1 is negative 0.1. So our a, which is a y-intercept, is equal to 0.1. So collectively, this helps us come up with a regression equation. What becomes our regression equation with the parameters that we have? Y is equal to what? Negative 0.1 plus the b we found is what? 0.7 times x. You leave the x as it is. So this is how we find the regression equation. So it comes from all this to all that. Then part 2, they'll ask you, suppose x is equal to 10. Predict y, because one of the rules for regression is to predict. So you simply substitute for negative 0.1 plus 0.7, where there's x, we put 10. So our final answer will be y is predicted to be 6.9. So this is how we do the regression. So with that being the case, we've been given an exam question here that we have 6 hours, we have 6 students studying for QM exam. So the relationship here is the hours of study and the exam score. So these are the parameters. So they've given you these parameters. Now they're asking you to calculate what? The coefficient
Coefficient
of
between.
correlation for the exam score. So before, I think that's the only thing I haven't taught you. Okay, so far any questions?
This is clear for me.
Okay, so okay, so if it's clear for you, here the exam want you to calculate the coefficient of correlation and also the prediction. Okay, let me look at the question that has to do with what I've taught you so far. So there are two questions that will come. So here we've been given a payroll in dollars. Okay, there's a payroll and the wins. So the data has been given to spoon feed you here. These are the results. Your B is 0.125 and your A is given by that. So What is the linear equation? Surely. This is a free mark. What is our linear equation? We're given a and b. So y is equal to what? A plus bx. What is our a? 67.5. And what is our b?
0.125.
Good. Then you just put an x at the end. Free marks here to write the regression equation. You don't even need to do the long cut I was doing because they've given you the answers. Then now they're asking you predict the wins for the team that received 90 million. So our x in this case is the value here. So you're just going to put, so one mark there. Where there's x, you're going to put what? Where there's x, you're going to put what? 90, right? Are we together?
Yes.
So the answer is what you get at the end. I'm not going to get the answer there for you. One mark for that. All right, so I am done with regression. I am done with Anova. So what is just remaining is a coefficient of correlation, which you can even read on your own. Thank you so much for your time.
Just reading.
Or you join the next session so that as I do that, I can take you through.
What time is the next session?
Sorry,